Hi everyone. Good morning. So good morning to all. So today is a new day and we are starting the sets in the PUC first. Okay, so that is the mathematics and you have learned so far several things about the already online classes are started. So today we are going to learn most important part, that is the first lesson of the first PU mathematics. Okay, let me start today's class. We will wait for one few minutes. Tell your friends to join quickly and let us start. Hi everyone. Hi. And this is a important lesson because you are not learned this previous year and all. This year you are going to learn this. Hi everyone. So what is actually what we have the set theory? What we will learn today? And it is good to if you will inform your friends to join here, so it will be good for you and good for them also. Hi everyone. So here the students, those are here, I think you are the learning the math, that's one science only. The online classes already started for you. So today we are going to learn the set theory. So let us learn that. Okay, let me start today's class. Welcome to PSM for Solution Math. I am your tutor Suman here. So today we are going to learn the set theory. In that the first lesson, that the first PUC chapter, that is the first lesson we have set theory. So what is the thing, what we set and everything we will go through this today. So you can see the screen. I think here the word given as sets. Sets is nothing but one common. That is it is a collection of elements. Okay, it is a collection of elements are called as sets. So actually, what is set actually? Because we are so many of you learned already this about the sets, but some of you are not knowing correctly what is sets and all. But actually, what is set now? Sets are nothing but is a collection of the object or elements. So for example, if you have one set, means or the collection of one a particular subject. Okay, so for example, I will take a natural number. If I will take a natural number is a collection of the number in which starting from one number, that is 1, from the infinity we are going to have. This is a collection of an numbers. Okay, for that purpose it is called as a set. Similarly, we have the lots of example for the sets. Example one more is that collection of whole number. This is also called as a set because here you can see, particularly we can say a set is of a collection of a number, so that is a natural number or it is a whole number and all. So I can take one more some examples for this. So I can take the collection of any other thing, that is the states of India. These are the example for the sets. So here when you are writing any, yes, you can take the real number also, collection of real numbers. You can take the collection of real numbers also. And these all are the example for what? Set. So one more important thing, so all these are the collection of objects or collection of a number or collection of any alphabet. Okay, you can take alphabets. All these are the we are going to call a set. So what is not a set? Which one we can't say that it is a set, it is not a set. So which one we can understand, which one we can say that which is not a set? Any you can give that, any example you can say it. So I can say one more thing, collection of top 10 intelligent people in the world. See, this is the set what we are going to take here. So it is a one question I given here. So what I given, collection of top 10 intelligent people in the world. So whether it is a set, whether it is a set, yes, whether it is a set, you can answer it to me. Whether we can say that it is a set, yes. Whether you can say that is a collection of set or it is a set, it is not possible. The collection of the top 10 intelligent people in the world, we can't take it as a collection of a set. It is not a set. Why it is not a set? Because tomorrow I can say I found, because for example me, okay, so I'm saying that there are top 10 people in the world, those are intelligent, are these are the 10 members or 10 peoples I can say. So I can give that A, B, C, D, E, F, G, H, I, okay, 5, 6, 7, 8, 9 and 10. So these are the 10 peoples which are those who have the more intelligent that I can say. But for others, they are not the top 10 intelligent people because we can't judge them. So this is by me, that is I am saying, okay, from my side. From my side, these are the 10 top 10 intelligent people. But from the others to from the other people, they are saying that these are not the top 10 intelligent people. These are 10 the top 10 intelligent people. So they will make you the any other name. They may suggest that it is not A, B, C, D, F, G, H, I, J. It may be M, N, O, P, Q, R, S, T, U, V, W. These are the people who those are more intelligent. So what will happen if we will take, the idea is not clear here. The idea is not clear because one people can say these are the top 10 intelligent people and the other people may say it is not, it is. So there is will be a discrimination between that intelligence. So we can't go with this word intelligence of the top 10 intelligent people and all in the set. So we have to go which is universal, which is universal means all the people know and all the people will agree. For that thing we can take as a set. For example, the whole number, if you go from India to any other country also, the whole number will not change, the whole number will remain same. The whole number is nothing but, yes, hi everyone, the whole number will remain same, that is starting from the 0, 1, 2 and so on. So what about the top 10 intelligent people? So I can say I am the intelligent. So you can say you are the intelligent. So there will be no exact the universal truth in behind this. Understood? So therefore, this is not a set. Only the set we will take it as which will have the clear idea, which is universal. That is most important word. Universal. It must be a universal. Means all must agree. Then only it is a set. Okay. So what is the definition of the set? you have already gone through the set theory because already the classes are started for some of you, and you have gone through the introduction, that is what is a set. So again, I have no need to write it down, but I will write it down once. The set, the set or a set, okay, set is a collection of a well defined well-defined objects, or you can write down elements as. So here the word, yes, yes, here the word, yes, hi everyone. So here the word, I have informed you how it is well defined. What is the meaning of this well defined? So just now I have given the lots of examples for you. So what is a well defined object, or what is a collection of the well defined? Here actually some students will get confused. So they will think everything is a set, example for set. It is not. It is the word says that well defined or distinct. They sometimes they will not give the well defined, they will give the word distinct. This is also the word they will use, distinct object. They may say that, or well defined. They will say what is well defined. Well defined is nothing but which is universal, which is truthful. For example, just now I have told the whole number, natural number, collection of the states of India, real number, and alphabets. All these are the well defined. These are well defined. But coming to the intelligent of the people in the world, or a top 10 richest person, that every day it may change. Every day it may change. So today, who is the richest person for India? Tomorrow may change. Okay, so we can't say it as well defined. So well defined is not the well defined. So a top 10 intelligent people, that is not well defined, because today some of them will take that this person is a well top 10 intelligent people, that tomorrow he may not, because one more person may get that place. Okay, so it is not the top 10 intelligent are not the set, example for set. A set is the example, this one you can take. Okay, and not only this, again you can take which is can be, yes, hi everyone. So this is the introduction for the set. So here some of the important things we have to remember. What are the important things we have to remember is some of the important notation they will give. So for example, when you are doing for the set, so there are some important notation, that is n we will call. What is n, what is z, what is q, what is r, and all these things you have to remember. And not only this much, again we will have several things. These are the basic what we have to remember. So n is what here, that is a natural number. You have to remember n is here called as a natural number, and z is called as a integer, all the integers. And coming to the q is a set of the rational number. Q is a set of a rational number, that is also most important. And then the R we have, so several students will get confused. Rational number they will take it as a R. Hi everyone. So rational number is not R, Q is called as a R, that rational number. The rational number is what then? Rational number, sorry, R is called as what? That is called as a real number. This is the important notation you have to remember. Okay, this is the important thing, that is N, Z, Q and R. We must know. We must know. And similarly, we will have one more, that is sometime we will take Z plus. Z plus is a positive integer. And sometime we will take Z minus, so it is nothing but the negative integer. So similarly, we will have the Q plus. So Q plus we will have, the Q plus is nothing but the positive rational number. So similarly, we will have Q minus also. It is nothing but the negative rational number. Remember this symbol because it will be useful. And R we will have, R is nothing but the positive real number. So R plus we are going to have, that is a positive real number. Similarly, we are going to have the R minus also. So there are several notation we have. Thank you, sir. So R minus we have, that is a negative real number, that is also possible. These are the important notation which you have to remember when you are going for the set theory. Okay, actually the set theory they have started in the first PUC, but in olden days, means 1 5 60 years back, 5 to 6 years, okay, 4 to 5 6 years back, the set theory was introduced in the SLC, means class 10. They were introduced in the class 10. Okay, now but it was introduced in the class 10, it was the easiest part for you, so you might have gone through it, but they have introduced in the post PUC, so you have to know about the basic first and quickly how to learn more. It's a very interesting lesson we have. So similarly the next one we will go move on to, and whenever you are writing the set theory, remember whenever you are writing any set, we have to starting with the capital alphabet, that is in English alphabet, that is capital A to capital Z. Any one we can select, whichever we can select from A to Z. Capital alphabet it must be. Okay, that is the two starting with the set. So similarly, what we will use, we will write inside the bracket. For example, if I will take A, that is equals to, I will write some numbers, that is 1, 2, 3, 4, 5. These numbers I have written. Okay, these numbers, what we will write inside the bracket, these numbers are called as elements or objects. So here 1, 2, 3, 4, and 5 are called as what? Objects or elements of a set. Of a set. So in the definition also I have given that a set is a collection of objects or elements. Here objects and elements are nothing but which will come inside of a set. What will define a set? Like this way, A is equals to 1, 2, 3, 4, 5. Here the 1, 2, 3, 4, 5 is called the object, or sometimes we will call it as elements of the set also. Remember this. So it is most important. And okay, and next one, when you are writing any set, for example, B is equals to, and we are writing the set A, B, C, D, E. When you are writing like this one set, most importantly here the capital B represent the set name, the set, what the name we have, that's the representation of the set. And here that small a, small b, small c, small d, and small e, again it is nothing but the elements or object of a set. So now most importantly is one more important thing, I will take it down, and all of you remember we will enclose the set using these brackets. Okay, that is called the flower bracket also. So this we have to remember, we will enclose by this. We can't enclose a set using like this. We can't use this. We have to use the flower bracket only. Okay, these are the important introduction for how to write down the set. Now anyone will you say, so if you have a set, there are two possibilities we have. There are two possibilities we have. Means whenever we are writing a set, there are the two things we will go through it. That is, I will draw some of the, I will write down some of the set. For example, I will write down, and you have to understand it. So I will take one set here, D is equals to, bracket I will put, and 1, 2, 3, 4, 5, and so on. What is this? Actually, what is this? What we can call for this quickly? What we can call for this? It is a set of what? I am asking, it is a set of what? That is the most important. If you understood this, it will be easier for you. It is a collection of what? Anyone? It is a collection of whatever numbers. You can answer if you know. It is a collection of some numbers. Whatever numbers you have to say. Set of natural number. Very good. It is a set of a natural number. Yes, very good. So it is a set of the natural number because it is moving on. So you can see the D is called as a, okay, here I can write it down directly. That is like this way. Okay, here only I will write down. It is a set of natural number. Because the starting number we know that d is, I can write on d is set of a natural number, we can write it. So most importantly here, that d is represented as a 1 2 3 4 and so on, means infinity it will move, so it is a set of the natural number. But I can write down that d set as like this way: d such x such that, here you can see most importantly I'm writing here x. This is a x is a one variable. What we can take your own. You can take anything. That is x. I can take anything. Okay, and in this two dots, what we have here, no, that is called as a such that. This is called as such that x such that. Next we will continue. X is natural number. So this is a representation of the set. Whether the, okay, I will change this name, instead of D, I will take it as E. My question is whether this E and D both are same or both are different. Whether this D and E both are same or both are different. Here X is a variable. Yes, X is a variable where X is the natural number I have taken. So whether such that, it is a symbol as such that, this two dot what we will put, that is such that we will call. So whether this D and E both are same or different. Both are saying the same thing or both are different. It is same. Yes, very good, it is same. I can take that d set is equals to e set, set d is equals to set e, but I have represented in a different way. Yes, both of them are not the same, we are represented in a different way. How you can say both are same? So for example, here we can see 1 2 3. Yes, the both of them have the same elements. So here this set E I can write down as x they have given, and x is the natural number they have given. So actually the natural number start from what? 1. Then the natural number is what? 2. The x value first, it may be 1 or it may be 2, it may be 3, it may be 4, means it is increasing. So every time the x value it will increase. And you can see the same value of this d and the same value of the e we have taken, but we can represent in a two different way. We can represent a set in a two different way. That is the idea behind this. So what is this first is called, you have already learned, some of you have already learned about this. So what is this is called and what is this is called, these are the two types of a set. We can represent a set in a two different types. The first one we have 1, and second one we have e. D and e we have, what we will call for the d, what is the name we will make you for the d? The simple one I have taken the example. So what do you mean by the d? Both the, yes, it is a roster method. Very good. This is a roster method. The first one what is given here, this is called as a roster method. Okay, roster form you can say. And this is the second one what we have, that is called as, the second one what we have called, it is a set builder. Set builder form. Do you know one more name for this? Yes. Do you know what is the one more name we can give for the roster form? We have one more name. So how we have written this? Okay, already given that answer. Okay, it is already one more given that answer. Yes, this is also called tabular method. Yes, this is also called tabular form. Okay, there are two names for the writing directly the element, that is a set roster form, and one more is a tabular form. Similarly, for this, the E what I have written here, the E what I have written here, we will call it as set builder method or set builder form, or one more name we have. What is that one more name? Do you know? I think they have not mentioned in your textbook, I think, but one more name we have for that. Yeah, second one is set builder form only. That is not the anything difference we have. That is, yes, that is a set builder form only. But I'm asking one more name. If you write a set builder form, it is good. No, no, roster form is the first one. Roster form is the first one. The first one is the roster form. That is tabular form we can call. I'm talking about the second one, that is E. Is set builder form? Yes, correct. One more name we have for this, for set builder form. Do you know? If you don't know, make a note of it. This is also called as a rule method. The second one also called as rule method. Remember this. This is important question. They may give in any other, okay, any one of the exams and all. Okay, any one of the exams they may give this question to you. So go through this. Okay, if they will give in an exam, that is for example you are preparing for the CET for second year, that time it may be the question, what is the one more name for the, what is the one more name for the set builder form? That is nothing but rule method. That is the important. Yes, very good. So this is all about the first half. That is the what we have learned: roster form, tabular form, set builder form, and rule method. But here some of you will get confused again. So what is the confusion you may have here? So I will put any one of the method and I will tell you to do one more method. For example, I may give the roster form for you and I may say that write it in a set builder form. So I will take one example, that is f I will take, and in a bracket I will take the numbers as 1. Okay, then I will take as a 4, then I will take as a 9, and then I will take the 16, then I will take the 25, and so on. So how you can convert this method, that is which method you can find, because here only I given two methods, different types of methods, the roster form and the set builder form. You can identify which method it is. After identifying, convert it into another method, which is this method, that is f, which is this method, which is this method we will call for that f is equals to 1, 4, 9, 16, 25. Which method we can say for this, whether this is a roster form, whether it is the set builder. Okay, quickly. So if you know, you can answer it quickly. Otherwise, if you don't know, no problem, I will write it down. So if you will see, okay, Siri with the answer, Siri with the answer, very good. That is very good, very good answer. But I am asking which method it is. That is a roster. Yes, it is roster. And after this roster form we have to convert, yes, after this we have to convert it into the set builder form. Set builder form, when it will come, only one thing we have to remember. Yes, yes, that is a correct. So we have to remember that Sandesh, it was the correct answer. We have to uh, find that what is the behind the logic behind this question. First we have 1, then we have 4, then we have 9, then we have 16, then we have 25. So what is the logic behind this? That is most important. Here the logic is the all the perfect square number, 1 square, next we have 2 square, next we have 3 square, next we have 4 square, next we have 5 square, and so on. So these are the square of a number, that is a natural number. See, because here we have 1 is a natural number, 2 is a natural number, 3 is a natural number, 4 is a natural number, and 5 is also a natural number. So it is a set of a natural number square, square of the natural number. So we have to write down that f is equals to, if we are converting to a set builder form, we have to write down x such that, this is most important. This one you have to write down, x such that x is equals to, I will take a new variable, that is n square. Okay, new variable I will take n square. You have to put the comma. You remember this comma is very important. N square, where that n is belonging to n. So very important. New one more new word you have found, that is belonging. This is called a symbol called the belonging. It is not e. It is not e. Okay, it is not e. It is belonging. Belonging means what? We have to put light space C, and in between we have to put one line. It is called as a belonging. Belonging to n. N here refers to what? A natural number, because I have given you what is that refers to. Here you can see n refers to a natural number. So this is most important to, we have to remember. So n belongs to n. The next part is continuation. N belongs to n, and this is your answer. Okay, so it is the total thing what we have to write. So where n belongs to n. Okay, okay, this is the one method of writing. So yes, again we have several methods of writing. So I think you understood this. So it is nothing but x we have to write every time, such that x is equals to n square. because the n square, because this is 1 square, 2 square, 3 square, 4 square, it is continuation. So here n refers to these numbers, that is 1 2 3 4 5 what we have now, that numbers are called the n. Okay, so these are n numbers 1 2 3 4 and 5, and that n is nothing but the natural numbers. Okay, this is a one type of a representation of the set builder form, set builder form. And we can represent this not only in this method, we can represent in any other method also, such that f x x is perfect square of natural number. We can write down like this way also. This is also possible, this is also possible. Yes, yes Siri, very good. So here this is also possible, so we can write down x such that x is perfect square of natural number, because here all the natural numbers we have, that 1 square, 2 square, 3 square, 4 square, 5 square, and it is continuation, it is continuation number. Okay, so this is also possible, so any one method you have to write it down. So now very importantly, one more, some of the important notation again we have to see. See, some of you don't know, this is belonging. Yes, this is called as a belonging, belonging symbol it is. Okay, belonging. For example, if you will take one any alphabet, that is I can take here S. S is equals to, and if I will write down that S is equals to 2, 4, 6, 8, 10, 12 and so on. These are the numbers when I will write. Here these are called the element. The 2, 6, 8, 10 and 12 are called the element, and most importantly these are the elements of which set? These are the elements of which set? That is element of S. So I can write down that 2 belongings to S. I can write down what? 2 belonging to S, means this is the 2 number. This is the 2 number which is a part of the set S. Similarly, I can write it down 4 belongs to S. Similarly, I can write it down 6 belongs to S. Similarly, I can write it down 8 belongs to S. Similarly, I can write it down lots of things. But whether it is possible to write down 16 belongs to S? My question is clear now. All of you listen, whether I can write down that 16 is belongs to S. Whether it is possible to say 16 is belongs to S. Hi everyone, those are joined now. My question it is clear as for you, yes? So you can answer to me whether this is belongs to S or what. Yes, it is correct. Yes, yes, Ananya Udupa, it is correct. Because the 16 is a part of the S. But here you may say, so here we are not finding any 16. How you have taken 16? In the given elements in a given set, there is not 16, you don't have the 16 in it. So how you can say the 16 is belongs to S? Because you can see this S is a number set containing the elements all, you can see, and logic you can go through it. What is the logic behind it? What is the logic behind it is all are even number, all are even number. And most importantly, if you see this, and I will write on T also, and if I write like this way, difference you can find. There is a lots of difference we have. What is the difference between this S and T? Yes, it is a even number. What is the difference between this S and T? What we can find the difference between S and T? It is most important. Some students will go wrong here. The difference we have in these two, and already you have learned some of you have already learned the set theory, so it is more than half is finished for you. So do you know what is the difference between this S and T? A simple difference we have. What is the difference? You may find it, and you may say both are equal. The S and T are both are equal. Yes, very good, Ananya Udupa. Here first one, S is a infinite set, means here we have so on. So on means it is moving on. Yes, it is moving on. The S set what we have, it is continuous, means it is not the end. Till we don't have an end for it. Okay, we don't have an end for this S. It is called the infinite. infinite set. Why we'll call for this infinite set? We will call for this as an infinite set because it have so many numbers. After 12 it is not terminating, it is not the end, it is continuation, the so on we have given. But coming to the t, here you can see after 12 I have stopped at the 12, so it is a finite. Second one t, what we have, it is a finite set. In a finite set, in what we have that finite set, we can find only number 2, 4, 6, 8, 10 and 12. That's all. Again further numbers we are not going to find. So it is called as a finite set. And the first one, it is S, is called the infinite because it is so on. Because the last number we can't find it. Understood the difference? I think you have understood it. So it is the most important, the finite and infinite set. So 16 is belong to S, but 16 is not belonging to S. Remember, not belonging refers to, you have to put the same symbol like C and one more line, and you have to put a dash for that. It means that it is not belonging. It is not belonging. So it is not belonging. The 16 is not, sorry, not S, it is T. Not belongs to T. Because in T we don't have that 16. That 12 is the last number. We don't have the 16 in it. So you can identify which is finite now and which is infinite now. I think you don't have any problem. Yes. Okay. And the next one we will move on to. Do you know what is cardinal? One more name I will suggest today. The cardinal. Do you know what is cardinal number? Do you know what is cardinal number? Okay, today I am going through the all the definitions what you are going to have in a sets. Okay, in a sets, what are the definition you are going to have, that all the things we will discuss today. From the next class we will go through your portion, how your portion, everything what you have, like that we will move on to. But this is the most important definitions that is necessary for you to study the set theory. So what is cardinal number? Quickly, if you know the answer, just you have to say to me the cardinal number we are going to say. The word cardinal. If you know, you tell me yes. If you don't know, you write down directly no. So cardinal number we will call, and most important in set theory. The next topic heading is cardinal number. So anyone know the cardinal number? If you are not replying means I think you don't know the cardinal number. So let us see. The cardinal number refers to for the finite set. Okay, which is finite set. No, for that set we will have the cardinal number. For example, the previous one, the t what we have taken here, it have the cardinal number 2, 4, 6, 8, 10, 12. What we will have now, that is the cardinal number we have. So let us take one example. So I will take directly, okay, no problem, I will say to you. So I can take anything. So I will take here m is equals to, so I will take the bracket and I will write down some numbers. Okay, that numbers are 2, okay, then 3, then we will take 5, then we will take 7, then we will take 11, then we will take 13, and okay, 17 enough, 17 enough. So I will stop it here. We will apply the cardinal number only for, it is only for what, finite set. We will not use these cardinal numbers for infinite set because we can't find for infinite set. So a cardinal number is nothing but, for example, in the set M, how many elements we have? How many elements we have in a set M? That is called the cardinal number. So how many numbers we have? How many elements we have in set M? That is most important. Count it. Count it. So I have told that cardinal numbers only suitable for what? Only suitable for finite set. So how many numbers we have? Count it. So it is 1, 2, 3, 4, 5, 6 and the 7. Very good, Sandesh. So here we have 7 numbers, that is 7 elements in a set M. So here cardinal number of M is equal to 7. So easy it is not the big thing. We have to apply only for the finite set, and we will call the cardinal number. Cardinal number is nothing but how many elements are there in a finite set. because we can't take for the infinite set because we can't count how many numbers are there. So let me take one more example. So I will go for the n. So n is equals to 4, 8, 12, 16, 20, 24, 28, 32, 36, and so on. So, okay, no, don't want so on. 36 is the last. So what is the cardinal number of this n? What is the cardinal number of this n? Most important is, okay, what is the cardinal number of, yes, very good, very good. Yes, Vandana, 9. That is correct. That is the 9 because we have to count how many. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So cardinal number of set n is 9. Yes, that is important, and I think you can understand cardinal number also, no problem. So one more important thing, the last one I will take, that O is equals to one more I will write down. So if I will take like this way, 1, 2, 3, 4, 5, 6, and so on. So what is the cardinal number of this set O? What is the cardinal number of the set O? Most important is, yes, very good. What is the cardinal number of the set O? Here, whether the cardinal number of set O is only 6. The cardinal number of the set O is 6. 1, 2, 3, 4, 5, 6. We have 6, so we can write down 6. Or is it not possible? Yes, we can't find. Yes, we can't find it because I have already told the cardinal number only refers for the finite set. We can't go with the infinite set. We can't go with the infinite set because we don't know how many points we have after 1, 2, 3, 4, 5, 6. We don't know how many numbers are there, and it is not possible to count. So can't find for this O. So we can write an infinite, but exact value we can't write. Exact value we can't write. It is an infinite set. Very good, all of you. So we can't find for those. So now my question is, the first one, that is M, is in a form of roster method. The M is in a form of the roster method. So will you convert this into a, okay, I will take little bit down. So this M set what we have now, that is in a roster form, whether it is possible to convert this roster form M to other form, one more form we have to convert, whether it is possible. Whether it is possible. So cardinal number we have learned. So I am asking the M set what we have, that is in a roster form. This is in a roster form. Whether it is possible to convert the roster form to a set builder form. We have to convert it into set builder form. Whether it is possible. Anyone? If it is possible, say it to me. If it is not possible, say no. No problem. You understood what is cardinal number? That is very good. So yes, you can convert. Yes, very good. You can convert and series with the answer. So when we are converting the answer, that is a form, first we have to learn what is the logic behind these numbers. The logic behind this number is all numbers 2, 3, 5, 7, 11, 13 and 17 are called as what? A prime numbers. Yes, it is a prime number. It is a prime number. So we can convert it into set builder form. That is nothing but M is equals to X such that, see here again I am saying this is such that, okay, 2 dot is nothing but such that X is a prime number. Whether it is correct? I can write down like this way, X is a prime number. Whether it is possible to write down like this way? Whether it is correct, what I have written, this is correct. Whether it is correct? Whether it is correct, or again anything we have to write it down. X is a prime number. Whether it is correct? Okay, prime numbers will be starting for the natural number only, or we can continue this. If you say this is the end of the answer, then you are going to get a wrong answer. This is not the correct answer. It is wrong. M is not only a prime number. Natural number also. Yes, it is a natural number. We can say the 2, 3, 5, 7, 11 and 13 and 17 all are natural number only, no problem. The prime number we will not have for the negative value. The prime number we will have only for the positive values. So prime number means positive only. Prime number means positive only. Continuation is there. Yes, very good. Very good answer that Ananyodupa. Till 17 means we have to write down here continuation we have to do. That is nothing but x is lesser than 18. We have to write down that x is lesser than 18. Remember, if you will not write down this, it is wrong. If you will not write down this, no, it is going for the wrong answer. Yes, because here prime number means it is not the end. 17 is the not last number. Yes, Ganesh, that is also possible, but no need to write down less than greater than 2 because the prime number start from the 2 itself. Okay, prime number start from the 2 itself. So again, no need to write down lesser than greater than 2. But it is the correct answer, that is x is lesser than 18, or we can write down instead of lesser than, we can write down less than or equals to 17 also. Less than or equals to 17 also, not less than 17, not less than 17, less than or equals to 17, that is also possible. Or if you don't know to write down the less than or equals to, you can go directly to the less than 18. No problem. So this is the whole thing what we can say the set builder form. So we have done the calculation. So most importantly here you see x is less than 18, that we have to write it down. If you not write it down, it is wrong. So coming to the n, again you can convert this n in terms of again the roster form. This is a it is a roster form. So roster, or we will call tabular form for this. We can convert this into a set builder form. So what is set builder form? So n is equals to, we can write it down x such that x is equals to, what we can write it down, x is equals to, here we can write down one more, two types we have that we can write it down. And what is the logic behind this? What is the logic behind this? If you will see 4, 8, 12, 16, 20, 24, 28, 32, 36, we have one logic. What is the logic behind this? Most important logic we have. If you understood the logic, we can write down the answer. So anyone? Anyone? So quickly you can answer it to me, otherwise I will write down, no problem. X such that x is equals to what? Divided by 4. Okay, all numbers are divided by 4, but we can't write down the divided by 4, but we can write down, yes, x is a multiple of 4. Multiple of 4. We can write it down, see, n is equals to x such that x is a multiple of 4, but we have to continue that x value is less than 37. That is, that we can find, yes, multiple of 4, and we can take here less than or equals to, okay, because x into 0 is 0, no, so that is also possible. So we can have to write down not this much only, we have to continue the x value is greater than 0 or greater than 3 also we can take, no problem, greater than 3, because you can see x into 0 we can make, we can write down x into 0, that is 0, so we don't have 0 here, so we have to write down x is greater than 3 but lesser than 37, most important. So this is your answer, but you can write down instead of this, you can write down actual method. We are not actually supposed to use these words, x is a multiple of 4, x is a multiple of 5, like this we are not supposed to write in sometime the teacher will not give the answer, means full answer, so some student teacher will not do that. For that purpose what we can write down is x is equals to, x such that x is equals to multiple of 4. So we will take 4 into n. We can take 4n. Yes, here you can see it is the exact form, that is x is equals to 4 into n. But here n is extra. This n we have taken extra. What is this n refers to? What is this n refers to? All of you see. Once I will show you what is this n refers to. Yes, very good. What is that n refers to? 4 into 1, 4 into 2, 4 into 3, 4 into 4. All these numbers, if you see, this is 4 is common everywhere. So I have taken 4. But what is that n refers to? N refers to 1, 2, 3 and 4, and it will continue. 4 ones are 4, 4 to the 8, 4 to the 12, 4 4 to 16, and it will continue till how much? 4 into 9, that is 36. Last number is 36. So the n value greater is 9, smaller is 1. So I can write on x is equals to 4 times n, where n belongs to the natural number. Okay, all of you see, all this n value is belongs to natural number. So I can write on n belongs to n, so that n value is lesser than 10. This n value is what? Lesser than 10, because 9 is the last number, so n is lesser than 10. Or instead of writing that n is belongs to n, you can write on only one sentence. Like this way also you can write it. Lesser than, greater than 0, but lesser than 10. Not 3, from the 0. 0, because you can see greater than 0 means 1. X value is 1, 2, sorry, n value is 1, 2, 3, 4 until 9. So all 9 numbers are there. Like this way you can write them. But sometimes we will write like this way. That is nothing but can this n belongs to capital N, that is natural number. So you may ask, sir, whether if you will write like this way, whether they will not give the marks. If you will write like this way, that is this form what you have written, whether they are not going to give the marks, definitely they will give. Definitely they will give. Both the correct answer. Both of them are correct answer only. This is a set builder. This is also set builder only. No problem. But practice to write like this way. Why am I saying like this way? Because the next problem I will show it to you. Take down the next problem. Very important, that problem we will solve, because in that time you are not going supposed to use this one. It is not possible to use. Okay, no problem. You can't use this one. So how you can write it down then? P is equals to, see here all of you, one more interesting question I will give. 1 divided by 3. Okay. Next number, that is 2 divided by, okay, 4. Next number, 3 divided by 5. Next number, 4 divided by 6. Next number, 5 divided by 7. So these are the numbers I have taken. For this, how you are going to write in a set builder form. This is a roster form. This is a roster form. This is a roster form. You have to write it in a set builder form. How you can write it down once again? Whether it is possible to write. See, whenever like this problem will come, we can take the two variables and we can note it down, but in simple way we have. Whether it is possible to write in a set builder form. But when you are writing the set builder form, we have to, yes, x plus 1, y plus 1. Okay, that is x plus 1 divided by 3 plus 1. Okay, so think correctly, no problem, think correctly. Yes, good answer. It is not the wrong answer I am saying. Simple way how to do. See, we have to use the simple way and we have to do it, not the big problem we have here. So logic behind this we have to see. Logic behind this is simple. We have the continuation number 1, 2, 3, 4 and 5. So this is not the problem. This is not the problem. It is continuation number. Okay, we don't have any problem in this, so we can take that natural number. So first one is the natural number, second one is the second natural number, third one is the third natural number, fourth one is the fourth natural number, fifth one is the fifth natural number, that we can take directly. That is the logic we have to identify. These are the continuation number, but the denominator plays very important. The denominators are also a logic number only. So here what they have given, you can take that continuation number from the 3, 4, 5, 6, 7. So you can take here this number as x and below number you can take the y. But don't take like that. Because I will tell you the simple way. Here we have that 1 on the top. Below 1 we can write a 1 plus how much? 1 plus how much? Here we have 1. So below also we can write a 1 plus how much? Okay. How much? 1 plus 1 plus how much is 3? That is 2. Yes, 2. So we can do here 1 plus 2 is equal to 3. Similarly, the other side we have 2 here. So we will write on the 2 here. And for the 2 again we will add how much? Again we will move on to the third one. The third part is the 3. We will write down the 3 on the down. Yes, 3 on the down, and we will write down here again 2. Yes, yes, Sandesh, it is nearby answer. Very good. The next number is 4. So we will take that 4 and we will add for that again 2. And next number is also 5 we have. So 5 we will write down. Again we will add plus 2. So this is the end. This is the logic. So you can verify it every time the same number what is in the numerator, same number we are taking the denominator. And one more important thing is everywhere the 2 plus 2 is common. The plus 2 is common. Yes, Siri, very good. That is Sandesh also given the correct answer and Siri also given the correct answer. But exact what which is the answer? So P is equals to, we have to write always x such that first. Then we have to write down x. Okay, x such that x is equals to, so remember again I can't take here x divided by x plus 2. Why I can't write down here x plus 2? Because already I have taken that x here, so I can't take once again x, because x get cancelled if you will take like this way. So you can't take this x, and logic behind every time is this is the same value, so here I can take n. So here I can take n. I am not saying that n only you have to take. You can take y, but don't take x only, because x already have used. If you used once, again you can't take that same variable on once again. So you can take n. So n divided by n plus 2. N divided by n plus 2. So here you can see the n value keep on changing. Natural number is keep on changing, but that plus 2 will remain as it is. Plus 2 will remain as it is. So I have taken a plus 2. So next is that what is this n refers to? What is this n refers to? Here the n refers to means belonging to capital N. Means it's a natural number. All are natural number. 1, 2, 3, 4, 5 are natural number. But till where? It is a continuation we have. Whether it is continuation? No. It is stopped at the, yes, it is stopped at what? 5, means we have to take that n value is less than 6. If you have 5 less than 6, or you can take equals to 5, less than or equals to 5, or don't get confused in this, so you can write down 6, less than 6. Okay, Siri, what you have written is not exactly correct. Siri, what you have written, that is not exactly correct. What you have written is here n is belongs to n. The n value is less than greater than 0 and less than 6 you have taken. Yes, it is correct. But why you have used that n is belongs to n once again? You are writing this means if you are greater than 0, if you are taking, no need to write this one, because it says that n value is what, from 1 to 5. If you are not writing here less than or greater than, then you have to write down here what, n belongs to n. The logic is simple. N means what, capital N means what, natural number. From it will start from 1 itself. It starts from 1 itself. Again the natural number will not start from the 0, it will start from the 1 itself. So again here no need to write down less than greater than 0. If you write greater than 0, simply you are writing yes. Yes, very good. So this is your answer. I think you hope you understood this. You understood this, the roster form and set builder form. So once again you practice it. In the next class I will go through it. And most importantly, today I will give the last introduction. I'm not going to teach. In the next class what I'm going to teach, I will tell you. There are types of sets. There are types of set. Okay. There's some types of set we have. That is also we have to learn. But sometimes what they will give is they will give the this form, that is a set builder form they will give, and you have to convert it into a roster form. That one example we will solve, and today we will conclude here only. Okay, one question I will take. Q is equals to x such that x is equals to n cube minus 1. Okay, n cube 1, n square you make it, so it will be simple. First example, no? So n square less than 1, so n belongs to whole number, and n is okay, this is enough, this is enough, this much is enough. Will you say that next continuation, what is the answer behind this? What is the answer you are going to take here? What is the answer will be? So what is the value of this q is equals to? So it is simple now. It is not the difficult. It is in a set builder form. Whenever the set builder form is given, no, it will be easier to find the tabular form or roster form. Roster or tabular form we will call for this. It will be easier. What is the value? We can write it down quickly. So what is the x q value will be? So first one, that is x is such that x is n square minus 1. Here n square refers to what type of a number? Here the n value refers to what type of a number? See, n is refers to not natural number. Remember, n is not a natural number. Yes, very good. N is not a natural number. N refers to whole number. N refers to a whole number. Remember, when it is a whole number, the n value may be 0 or value may be 1, it may be 2, it may be 3, it may be 4 and so on. So here you have to remember, every time the n value is a natural number is wrong. The capital N value is a natural number. Capital N value is a natural number, not the small n value. Yes. So what is the answer going to be? So here according to the question, the n value is w, that is nothing but 0, 1, 2, 3, 4. So substitute one by one. First we will go for this, here n value we will take it as 0 square minus 1. What is 0 square minus 1? That is the first value. Second value, we have to increase that n value by 1. So 1 square minus 1. Second value is 1 square minus 1. Third one, we will have to increase by 2. Here 1 is finished, now it is 2. So next is 2 square minus 1. Next again increase 3 square minus 1. Next again increase 4 square minus 1. The n value keep on changing. I have given, so this is the trick they will use. Remember, this is a small trick they will use. Every student will think that when it will come n, it is a natural number. If you will think that n, small n is a natural number, wrong. Small n is not a natural number. Small n refers to the next part what they have given. It refers to w, means whole number. So what is 0 square is 0. 0 square is 0 here. I am talking about here. 0 square is 0. Minus 1 is 0 minus 1 is how much? Minus 1. So I can write down here minus 1. The next one, 1 square we have. 1 square is 1. Minus 1 is how much? 1 minus 1 is 0. Then 2 square is 4. 4 minus 1 is 3. Then 3 square is 9. 9 minus 1 is 8. The next one is 4 square minus 1. 4 square is 16. 16 minus 1 is 15. Whether this is the end? Whether this is the end? Whether this is the end, or again we have numbers? Again we have the numbers. So this is the most important again it is the most important. So it is not the end. Why it is not the end? Because they have not mentioned in the question n is belongs to w, that's all they have given. Means again so on numbers we have 5, 6, 7, 8, 9, 10, 11, 12. It will continue. Yes, it will continue. So it is continuation, you have to put the dot. This is most important. If in the question in the set that is q is equal to what they have given, no, if instead of that, if I will take r is equals to like this way, x such that x is equals to n square minus 1, where n is belongs to w, and next question they have given n is less than 6. If they have given n is less than 6 or n is less than 5, if they have given n is less than 5, then the answer is n value is 4. N value is how much? 4. Last number is 4 because it will start from 0, 1, 2, 3, 4. Because less than 5 they have given. N value is less than 5 they have given. So last number is 4. The R value may be minus 1, 0, 3, 8 and 15. This was the answer. But they have not mentioned here less than 5 or less than 6 in the Q. So we have to write down till here. So this is the infinite. So this is the end of the today's class. So in the next class we are going to learn the types of sets. So types of sets, we have lots of sets. So there we will have one confusion. The first one we can go through the finite. Second one infinite, that we have already learned, infinite. Third one we have the singleton. Singleton we have, or it is also called as a unit set. Next we have empty set, empty or null set we are going to call, or it is also called the pi. Okay, that is pi also very important. The next one we have a joint or overlapping set, joint or overlapping. So these are the types of set. In your textbook they have not given about all these things, but these are the types of set we have. Next one we will have disjoint, just you can make a note of it. And the next one is a very important, the seventh one and eighth one, what do we have now? Okay, it is most important, that is equivalent. We have equivalent set we have, and next one is equal set. These both will confuse a lot. The last two are confusing a lot for some students, but if you see that logic correctly, and it will be easier for you. Okay, so equivalent and equal both are same or both are different. Let us learn in the next class. So next class when it is, I will inform you. So we will have to be see in WhatsApp, you can take the status and all, and you can check in Instagram, you can check in a Facebook also. There I will put the next date and timing for you, and we will learn such a way. And tell your friends to go through this once again, and tell them also subscribe my channel and like once again all of you. If there are lots of people are coming for the class, I will take, if you want, daily or once in a 2 days. Otherwise there are some students are coming, means I will take once a week. So it is depending on the students, how much students are going to come here. And very thankful for you because all of you are here for the last 1 hour. Thank you one and all. So see you in the next video. Till then, take care. And one more important thing, so tell your friends to join and subscribe my channel. Thank you. I think it will be helpful for you today. At least 1% you understood today. Okay, thank you one and all. Stay safe.